Hello students, welcome to the wonderful world of mathematics. In this module, we are starting with the chapter Continuity. In continuity, we require some basic concepts. So, what is that? That is a limit of a function, and you already have learned this in your earlier standards. Now, in this chapter, we will discuss the continuity of a function, which is very closely related to the concept of limits. So, what is exactly a continuity of a function, right? What does it mean for a function f of x to be continuous at some value x is equal to a? So, let's learn it first in an informal way. What is it? A function is continuous if you can draw it in a one motion without picking up your pen or pencil from paper. What is it exactly? If you have an x-y-axis graph with you and you have a pencil or a pen, and in this case, if you want to draw something like a sine wave, you have observed that you can draw it in a very smooth way. Rather, you have drawn this without picking up your pen or pencil. So I can say that it is an continuous function. Now let's go into the concept. What is it? If you have a and f of a with you, you can observe that yes, it is a curve and it is a continuous curve. How? Let's have a look at it. Its coordinates are a comma f of a, and you can draw that complete curve without picking up your pen or pencil. Now let's have another example of, over here you have a and f of a respectively again, but at point A your curve stops, and again from that same point A, but the y coordinate changes. In this case, while drawing this, you will have to pick up your pen or pencil from the lower point to the upper point, and hence I can say that this is not continuous. So I can say f is not continuous at point x equal to a, and hence I can say f of x is discontinuous. Moving ahead. What do you mean exactly by left hand limit? We already know that anything which is on our left side is called as a left hand limit. So, if you have a point E and the integers on its left hand side, so it is a minus. So, when the equation is limit x is tending towards a minus into f of x, denotes the limit of f of x when x is approaching to a through the values which are less than a, and hence it is left hand limit. Therefore, the left hand limit is equal to limit x is tending towards a minus f of x. I can also write it as limit x is tending towards a where x is less than a into f of x. Now let's go on to the right hand limit. It is exactly opposite to the left hand limit. It's on the right side. So a value should be positive. So equation is limit x is tending towards a plus f of x denotes the limit of f of x when x is approaching towards a through the values which are greater than a. Hence it is plus a. So I can say that the right hand limit is equal to limit x is tending towards a plus f of x, and which is equal to limit x is tending towards a where x is greater than a into f of x. Moving ahead, note this point. Limit x is tending towards a minus f of x and x is tending towards a plus f of x are not always equal. Why, how, when? This is what we are going to do in this chapter. So, if I can say limit x is tending towards a, f of x exists. If and only if limit x is tending towards a minus f of x should be equal to limit x is tending towards a plus of f of x. So in other words, if the left hand limit and the right hand limit. They both are existing. Only then I can say that limit x is tending towards a, f of x will exist. Thank you.
थ्योरम है इसको बोलते हैं कि नहीं बोलते?